In the past videos, we looked at creating template graphs to look at multiple pieces of equipment with a single graph. Now we're going to look at making filters to allow us to analyze the data that's shown in the graphs. And for that, we're going to use value filters. In this tutorial, we can also use schedule filters, but this tutorial is going to focus on value filters. So in this example, I have cooling tower 100 and cooling tower 101. And I will take a look, using filters, at the times when the cooling towers appear to be out of capacity to detect when there might be problems in operations. The way to do that is to look at the fan speed of the cooling towers and to look at the times when the fan speed is high. So to figure out how to make a filter, I will look at just the fan speed to begin with. I'm going to make a new chart here and call it fan speed, and drag in the cooling tower 100 fan speed right there. So we can see most of the time it's low, below maybe 30 Hertz. That scale, by the way, tells us from 0 to 60 that this is probably Hertz, or 0 to 100% motor speed. And so I'm going to look at the high fan speed as a range of, let's say, 40 to 60 Hertz as an indication of when the tower might be out of capacity. So I will make a new value filter and call it high cooling tower fan speed. You can see up at the top, just like in the UT2, there are bins that I can define. I'm going to start with one simple bin, which will be 40 to 60 Hertz in terms of speed. I could, of course, make multiple bins, such as 30 to 40, 40 to 50, 50 to 60 Hertz, and so on and so forth. For the sake of simplicity, I'm just going to take one. Where the power of multiple bins also comes in is for electrical rate schedules. So I can define various, in terms of electrical rates, usually periods of time, when rates become multiplied with certain factors, and then using the filter and the electrical power input, I can actually calculate dollar values for rates. But in this example, I'm just going to look at the high fan speeds, 40 to 60 Hertz, and then rename that bin as well to fan high speed. Everything that isn't defined in bins in terms of either values or, in the case of schedules, time periods, is automatically collected in the default bin. So the default bin takes all the data that isn't defined elsewhere, and in our case that's going to mean the default bin will contain all fan speeds from 0 to 40 Hertz. I'm going to apply that filter by clicking on the channel, and just as we did for template graphs, I'm going to look at the definition of the channel itself. So scroll down to the bottom of the properties, and when I open it up, it's a simple static channel because I just dragged it in there, but I'm going to make this a advanced selection, and in this case not to make the channel variable but to apply a filter. So when I've applied the filter, now automatically I see only the values from 40 to 60 Hertz, and it's rescaled it. I might want to look at multiple sets of filtered values of this channel, so I can take the same channel and drag it in there again, which in effect means two traces in the chart of the same channel, and I'll filter the second one using the other bin, which is in our case only default, so it'll take everything from 0 to 40 Hertz. So I can split up a certain channel into multiple sections that can each be used for analysis and further calculation. So it doesn't just show them this way, it allows you to actually calculate other channels with that result. Now I will look at the composite chart that we made earlier, and in here I want to look at what happens to my supply and return temperatures when the fan speed is high. So those are dark blue, light blue up here for return temperature and supply temperature, and I'm going to apply that same filter to them. Scrolling down again in the properties, apply the cooling tower fan speed. Now these are not static channels, but they're already defined in the advanced menu as searching for words. So now I'm going to apply the filter, and in this case I don't really want to see the return temperature when it's between 40 and 60 degrees, so that the values in that filter should apply to the fan speed for that tower. So the filter itself also gets a dynamically selected channel, and in this case I'm selecting by speed. So the fan speed of the tower will be the trigger on which the filter is controlled. So the control input for the filter is not the return temperature itself, it's the tower speed. So I'm going to see whatever values the return temperature has when the tower speed is filtered between 40 and 60 Hertz. And since the tower speed is also dynamically selected, it'll switch along with the folders that I'm selecting. So either Cooling Tower 100 or 101 speed as I change the graphic. So there we are. Return temperature is now shown only when the fan speed is high. I'm going to do the same thing for the supply temperature. Apply the same filter again. Now the filter is already applied here for the fan speed, since I've done this a couple of times in the example. I haven't done it yet for cooling tower speed itself, so I'll add that as well. And there I don't need a control input because of course the fan speed is the selection that I want to use. So I can zoom in now, showing only the areas where the fan speed was really high. And there's only a handful of those. So first set of values here appears to be in, let's zoom in just a little bit more, appears to be in late September there, September 30, October 1, October 2, and October 3. And I can see the values as I mouse over them. For the Bay Area, that's not surprising. The supply temperatures here were around 70 degrees, 69, and 70 here. So that means the weather was probably warm enough to push the tower up against its limits. For this particular project, I don't really want to see supply temperatures from the tower of 70 degrees. And that just means the tower size was selected such that I'm quite at the limits here of my capacity. There's another example over here. This was later. So this is November 6. I wouldn't normally expect November to be that warm. I can see that the supply temperature here isn't actually warm at all. It's right at set point of 66. So in this case, I think I have a exceptionally high load on the tower rather than the weather pushing it up. So that helps me analyze the actual performance of the tower. I can now switch. Once I've looked at Tower 100, I can switch over to Tower 101 as we did before. So going to the chart properties at the bottom left, I'll select the folder 101 instead of 100 for the tower, and I'll see the values change, and now I can analyze that tower in the same way. And that's how I can use value filters to help me make sense of the chart contents.